Hi everyone, we are going to do the last topic from graphical analysis of functions today, and that's end behavior. What end behavior refers to is what is actually happening at the ends of the graph. In other words, on the far left and right ends of the graph. So we have the left end, which we'll say, okay, well, what's happening is the x values go to negative infinity. So the notation for this would be, if we want to look at the left side, we would say as x goes to negative infinity, which is looking at the far of the function, then we'll say f of x, or y, goes to what? In other words, what are the y values? What's happening with the y values as x goes to negative infinity? By the same token, we have the right end behavior, which says as x goes to positive infinity, f of x is going to, and those values are going to be different. So whatever's happening with the y values, that's what we're going to write. All right, so what we're going to do is we're going to use the graphing utility Desmos, and we're going to graph a couple of functions, and then we're going to identify the end behavior. The first one that we're going to do, we're going to look at is y is equal to 3 times the quantity x plus 1 cubed. And we're going to go ahead to the Desmos, and we're going to put that in here. 3 x plus 1 quantity cubed. And over here we can kind of see the function, but we might zoom in a little bit so we can kind of get an idea of what's happening. Notice that as we move to the left, the y values are going down, and as we move to the right, the y values are going up. So the way we would write that is we would say, for the left end behavior, as x goes to negative infinity, remember that on the left-hand side, take a look, on the left-hand side over here, we are going down. So, resume. As x goes to negative infinity, f of x, or the y value, is also going to negative infinity. And then on the right-hand side, it's going the opposite direction. So as x goes to infinity, f of x goes to infinity. And let's just verify that by taking a look at the graph one more time, right? As we move to the, as we move over here, we're noticing that our y value is increasing. Okay? All right. So, coming back over here, let's look at another function. The second function we're going to look at today is f of x is equal to 3x to the 4th minus 2x squared. And let's take a look at that in Desmos so we can see what's happening. And if we type that in, 3x to the 4th minus 2x squared. Okay, I'm going to need to zoom out for this one so we can see it a little bit better. And so what we're seeing here is that as we move to the left, our y values are going up, but also as we move to the right, our y values are going up. And on the very ends, we would expect our y values to be very high on the left end and on the right end. And so if we want to write this in end behavior notation, we would write as x goes to negative infinity, f of x goes to infinity. And as x goes to positive infinity, f of x goes to positive infinity. They can be the same, and that's okay. Notice that for end behavior, you've got to write both the left and the right ends to have it correct. All right, the next example that we're going to do which I've managed to lose. Okay, so the next function that we're going to take a look at is y is equal to 2 over x. Now, if you think about that, what kind of function is that? And then that will have something to do with what we see when we go ahead and take a look at the function in Desmos. So in Desmos, we're going to pull that one up and take a look at it. And that function is 2 over x, and we're going to see this. And I think we're going to need to zoom out again to kind of get an idea of what we're seeing. Now notice here, as we move to the left, on the far reaches of the left, we expect this to continue, and it's going to get closer and closer to the line y equals 0, but never quite touching it. So it's approaching 0. But notice this, it's doing the same thing right here. And so as we move to the right-hand side, the end behavior is also going to 0. So let's take a look and see how we would write that. All right, so the left end behavior will be as x goes to negative infinity, f of x goes to 0. And as x goes to positive infinity or infinity, f of x also goes to 0. So it doesn't always have to go to infinity, and that was kind of a good example for us to look at. Remember, it doesn't mean that we're ever going to reach it necessarily, but that's what we're moving toward. Okay. So now, the last function we're going to look at today is y equals negative 4 over x squared. Now think about what kind of function that is again. And while this one was a rational function or an inverse function, this one is an inverse square. So this one is negative 4 over x squared. Similar, but not the same. Now notice, though, that our end behavior is really similar, because as the x values decrease and get further and further away from 0, we get closer, and the y values get closer and closer to 0, never quite reaching it, but the same thing happens on the right-hand side. And so as we write out this is going to look really the same as what we had before. So end behavior is not necessarily unique when we describe it in its description. So for this last one, f of x, as x goes to negative infinity, f of x approaches 0, and as x goes to positive infinity, f of x goes to 0 also. So very, very similar to what we saw before. Okay, I hope this helps clear up end behavior for you. Thanks.